All right, we're going to start off by reviewing a little bit about what we should know about polynomials. Polynomials just means many terms. Each term is separated by addition, and each term has a coefficient, something in front. So we have coefficients all the way along the way, and we have a variable, and we have a degree. Now, so an example would be like x to the 6th plus 3x to the 4th minus 2x squared plus x plus 4. That'd be an example of a polynomial. Now, each term has a coefficient. This would be 1, 3, -2, 1, and 4. And each term technically does have a variable and an exponent. This one would be x to the 0, because it's not really there. The other thing I want to note is that some are missing, right? Like x cubed and x to the 5th. That would mean it has a coefficient of 0 if it's not there. And we always write them in descending order. The largest exponent is considered the degree of the polynomial. And we can name them special by their degrees. Degree, the name. And let's do an example too. Okay, if we have a degree of 0, what that means is we just have x to the 0, since it's really not there, so we really just have some number. That's called a constant. We have a degree of 1. That means we have maybe 3x minus 7. Because we have the highest degree on that polynomial is 1. We should recognize that. That's a linear function. That's linear. Degree of 2 means that we would have x squared is going to be our biggest. It could just be by itself. That would be a monomial, one term. Could have 2 terms. That would be a binomial. Or it could have 3 terms. It's a trinomial. This is a monomial. Constant monomial. This would be a linear binomial. And 3 terms would be a trinomial. Now, if we remember correctly, this is a quadratic. And if you're wondering where quadratic comes from, x squared, when you square things, it's usually when you're finding area, and area of a quadratic, kind of where it comes from. 3 would be x cubed, so this is cubic. Now it could be x cubed minus 1, it could be x cubed plus 4x, whatever falls behind it. But that just means cubed is the largest one. 4 is quartic. So I would have maybe 3x to the 4th minus 2x. You don't always have to have every term. 5 is actually called a quintic. So you'd start off with x to the 5th plus and other stuff after that. So some of the things we need to remember are how to work with each of the terms, especially when we're simplifying polynomial expressions. I just want to remind you that when we were adding or subtracting terms, remember that the variables and exponents have to be alike. So if we had 2x squared plus another x squared, that would be 3x squared. You're just adding the coefficients. Nothing happens to the exponent. They're on different levels. exponents have to do with multiplication, so they don't get involved until we go into multiplication, that next level of your order of operations. Now, if they're not alike, remember, not like terms you can't do anything with. You can't simplify. So coefficients are involved from the very beginning, from adding and subtracting terms up through multiplication. But exponents don't get involved into the next level. So let's review the rules of exponents. Okay, the first one I want to review is when we have a product, or when we multiply. So what I want to do here is I'm going to write kind of the name of the rule over here. And then we're actually going to do an example and then talk about what happens more specifically in generic terms at the end. So we use real numbers in the example and then do the generic after that. So when we multiply, whoops, I didn't mean to put that there, multiply. When we multiply, we might have, I don't know, x cubed times x squared. Remember, this really means x times x times x times x times x. That means I have 5 x's all being multiplied. That's x to the 5th. So the generic form is if I have anything to a certain power, times the same base to another power, we add the exponents. Okay. What about divide? Well, gosh, just the opposite. If I have x to the 5th divided by x squared, remember what that really means? That really means x times x times x times x times x divided by x times x. Two sets divide out, so I'm just left with x cubed. The shortcut there would be that we could subtract. That is the rule. Now, the one that is most messed up is actually power to a power. Power to a power. That's when I have, let's say, x cubed squared. Remember, when you square something, that really means to take x cubed times x cubed. And we just talked about if we're multiplying them, we add the exponents. So that would be x to the 6th. So the rule there is when we have a power to another power, you're going to multiply. The way I've told my students to remember that is 2 in the sky, you multiply. Now, we also need to look at what happens if we had 2 things in there. 2, let's change it up, 2x squared, all of that cubed. Remember, that's going to mean we have 2x squared times 2x squared times 2x squared. Or isn't that the same as doing 2 cubed and then x squared cubed? Yeah. End up with 8x to the 6th. So when we have a product inside, something times something else, all to the same power, each of them do receive that power because this is multiplication and exponents have to do with multiplication. Now, the same isn't true if they were being added inside the parentheses, but multiplication, since it is that next level up, it does apply. Now, the one that's most frequently missed is when we have a negative exponent. And I really want to talk about where that comes from. So we're going to put up here negative exponent. And then we're going to really work through it. Negative exponent. A negative exponent comes into play whenever you have something like, let's say we had x squared over x to the 5th. Now we're going to look at it in two different ways. Let's look at what the rule says. The rule says we would have subtracted those. So x squared minus 5, that's 2 minus 5, which is negative 3. But if we watch what's really happening there, that's x times x over x times x times x times x times x. These divide out. We're left with the 1 that's in front, that coefficient, and we're left with x cubed on the bottom. In the math world, we prefer to not have negative exponents. Do you see that either way we do it, these two things are the same? So x to the negative 3 is really 1 over x cubed. So that would mean that x to the negative 2 would be 1 over x squared, and so forth. Now, a good point to note is that if the negative exponent had been on the bottom, you see how we're doing reciprocals? The reciprocal of that would be to put it on top. And if you want to relate that, it's very similar to your inverses. The last one, and I don't have too much room to do it in, is when we have, let's say, x squared over x squared. The rule says we'd subtract the exponents, so we would get x to the 0. Well, what do you really get when you divide something by itself? Heck, you just get 1. So anytime you have anything to the 0 power, you just get 1 back.